So today's notes, we're going to be looking at horizontal shifts, which are also known as phase shifts. And we've looked at horizontal shifts before, so here it is in function notation. If we are adding a constant inside of a function, that's a shift to the left, C units. And if we are subtracting a value inside of a function, that's a shift to the right, C units. And we've been looking at these vertical shifts which affect the midline. So we know that adding a value to the outside of a function is shifting the function up d units, and subtracting something to the outside of a function is shifting everything down d units. So let's just write these transformations. So if we just look at sine of x minus pi, so the fact that this is in parentheses means that that's a horizontal or a phase shift to the right pi units, and then the plus 3 is up 3. And I'm looking at cosine of x plus pi over 3, so that's to the left pi over 3 units. The minus 4 is down 4. Now these next two, the rule only applies, this plus c minus c, about the number of units shifted if this is just 1x. So we've done this before with other functions. We have to factor this number in front of x out so that it's just x plus. And then what would this be? If you're factoring a 2 out, it really means you're dividing each term by 2. So this would become pi over 2. Another quick way to see if you've done that correctly is just imagine that you distribute this 2 back through. Would you get back to 2x plus pi? Okay, so this shows me the value of the transformation. So it's not that we shifted to the left pi units. We actually shifted to the left pi over 2 units. And remember, the 2 that's there, that affects the period of the graph. The period is 2 pi divided by 2. So this is one of those graphs that's undergone a horizontal shrink, and it's going to get shifted left, pi over 2 units. The other graphs, by the way, had a period of 2 pi. This is just 1x, so 2 pi over 1 is standard period for sine and cosine. All right, one more example before we graph these. So if we take a look at this, first we need to rewrite the function to really see how it's been shifted. So factor a 1/2 out, so that this just becomes x. Remember, factoring a 1/2 or factoring anything out means dividing the value by what you're factoring out. So what's pi over 4 divided by 1/2? It's the same as pi over 4 times 2. So that's actually minus pi over 2. And if that's kind of hard to think about, again, if you want to check your answer, can I distribute this 1/2 back through and get what I had? So this is easier for most of us to see that 1/2 times pi over 2 is going to give us that pi over 4 that we had. There's still a plus 1 out here. Nothing gets factored out of that. So this graph goes to the right, pi over 2 units. It's shifted up 1. And then might as well do the period while we're looking at this. So the period is 2 pi divided by 1/2, which is 4 pi. So how do we graph these things? Kind of like we did with the midline. Let's look at shifting the y-axis. We can almost call that like the starting line, I guess. Let's shift that starting line left or right to give us a new visual. These axes are a little different. I didn't number them, or I didn't have the same window, so we get to mark off our own axis here. We'll talk about that in a second. So let's go through all the information for this first. Amplitude here is 1 because there's a 1 in front of the sine function. The period is 2 pi divided by 1 because there's a 1 in front of the x. So the period is 2 pi. I like to pause right there. And let's just make this first tick mark here, 2 pi. When you get the period, you mark off the end of the period. You cut that in half, cut that distance in half, and make the halfway mark between your middle and last point. This gives you the points for a sine graph, which I always like to sketch. Sine graph starts at its starting point on the midline, and then it goes up, midline, down, midline. Amplitude tells you how far above the midline and how far below the midline to go. All right, what about the shifts? We are shifted to the left pi over 2. So let's look at this. Just like I would do a midline shift, if this got shifted up 1, I would draw a line through the midline. Let's draw a line where the normal starting point is x equals 0. Let's shift that to the left, pi over 2 units, and let's just sketch that in. So here's the new starting point. So if you do that, it kind of gives you a nice visual for, okay, here's my new y-axis. And I'm just going to sketch the shape of the sine graph. I'll do domain and range. I like to do that after I get the graph. So this is a sine curve. Sine curve starts on the midline at its starting point. So it would have been 0, 0, but we went left. This saves us from shifting every point left by doing this. And then the next point should be the amplitude above. So 1 unit above the midline. And then we come back to 1 unit, or I'm sorry, we come back to the midline and then 1 unit below and back to midline. So instead of the graph starting at 0 and ending at 2 pi, it starts at negative pi over 2 and it ends at 3 pi over 2. So here's one period of the sine curve. Excuse me. Now, on the homework today, I have our normal grid, so I would like you to keep graphing the rest of this, but let's just show arrows to extend this, knowing that we could continue this periodic behavior to continue on. Now, what about domain and range? So the domain of this function, it's a sine function, so it's all real numbers. Goes on forever in both directions. The range, remember these arrows just indicate that the pattern, periodic pattern, will continue. So the range goes from -1 to 1. All right, so that's the first graph finished. Let's look at a cosine graph. So this cosine graph has an amplitude of 2 because of the number in front of cosine. That means that when we sketch the cosine graph, it starts at its amplitude, and then it goes to midline, and then below midline, midline back up. We have a period of 2 pi divided by 1 because there's a 1 in front of the x, so 2 pi. Let's mark that off right away, just like we did last time. 2 pi, cut that in half. Now, I know when the period is 2 pi that maybe you have these little tick marks memorized already, but the idea of cutting in half and cutting in half is nice for if the period is anything, we should be able to multiply that by 1/2. And then to get the other tick marks, multiply those by 1/2 to see what they are, if this is something other than 2 pi. All right, and then the shifts, we are going to the right pi units. So again, we can say instead of starting at the y-axis, start to the right pi units. So this line going through x equals pi is like our new starting point. Now that means I need to shift some tick marks over too, though, right? Instead of the graph ending at 2 pi, it's going to end at pi. Or another way to think of this is like you've just passed 2 tick marks, so you're going to need 2 more. And it's a good idea to label them: 3 pi, 2.5 pi. Oops, and there's a midline shift too. So we also are going up 2 units. So not only did I draw a new starting line, let's also draw a line through y equals 2. All these little guidance lines are totally optional. I think they make the graphing much easier, but they're not a required part because they're not actually an official part of the graph. They're just guidelines to help us. All right, so that means I should probably extend my y-axis up a bit and mark off, let's see, 1, 2, 3, 4. So on the cosine curve, at my starting point, the first graph starts 2 units above the midline. The next tick mark is on the midline. The next mark is 2 units below the midline, so I should be at 0 there. And then at 2.5 pi, we're back at midline, and we end at 3 pi, back up at 4. And again, on the homework tonight, fill the rest of the grid. But for these notes, we're just getting the 1 period down because that's the hard part. And then the rest is just using the periodic behavior, the pattern, to fill in the rest. Okay, what about domain and range of this one? So domain is still all real numbers. And the range, instead of -1 to 1, it's been changed by both the amplitude and the vertical shift. So now it's 0 to 4. All right, let's do a cosecant graph. We have some rewriting to do on this one in a few ways. So first, let's think of it as a sine graph. And we have to factor the 2 out. So if you factor 2 out of 2x minus pi, you get 2 times x minus pi over 2. So the amplitude is 1, the number in front of sine. The period is 2 pi divided by 2. The shifts are going to be to the right pi over 2. Oh, sorry, simplify the period, pi. So to the right pi over 2 and down 1. And we'll do domain and range when we're finished. So let's mark off the period. Now, again, we're only going to do one period, so these are the really kind of small, annoying graphs. On a quiz day, I won't give you a lot of graphs where the period is pi, but you can expect one. All right, so the period is pi. We cut that in half. We cut that in half. So pi over 4. Every tick mark is pi over 4. And this is a sine graph first, and then we'll do cosecant. So remember, the sine graph starts at the midline, goes up, midline, down, midline. We have 2 shifts to make. So our starting point should really be to the right, pi over 2. And because that's 2 tick marks over, let's add an extra 2 tick marks so we get our full period. So this is going to be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This is 5 pi over 4, and 6 pi over 4. Or you can say 2 more tick marks. We shifted pi over 2 to the right, so we'll be at pi over 2 over here. And we also need to do the midline. The new midline is at -1. So those dotted lines that I'm putting in, it's kind of like this is my new origin. This is my new x and y axis, and I just treat them like that. So let's put in a little stencil of a sine curve, because remember, we're trying to do cosecant. So sine starts at its origin here, and then it goes to its amplitude above the midline. So at 3 pi over 4, you're on the x-axis. Midline at pi, 1 unit below, and then back to midline at 3 pi over 4. Now, with all the dotted lines and stuff, it can get confusing. I would encourage you to use maybe, some people use highlighters and things for vertical asymptotes. You can use all pencil if you want, but the first asymptote is where I drew that sort of starting point. And then the next one would be at pi. And the next one would be at 3 pi over 2. Remember, we pick those based off of where the sine curve hits the midline, because that represents where the sine function is equal to 0 before it gets shifted down or up. And then sketch in the branches. So remember, they open away from the midline, and we just kind of fit them into the width of the vertical asymptote. So here's one period of this cosecant curve, and of course we would extend it for our homework. Now domain, you have to think a little bit harder about for secant and cosecant. This is going to be all reals. X is not equal to. So remember, you can always do this by just looking at the pattern. We would have, the next one would be at 0. They're all pi over 2 apart. So these are 1 pi over 2, 2 pi over 2, 3 pi over 2. This is all of the multiples of pi over 2. Pi over 2 times k. It's not like just the odds or just the evens. So maybe you can just get the pattern from the graph. You could also sort of look at the unsimplified version. It always works to pick the first asymptote that you drew, add to that the distance between the asymptotes, which is pi over 2, and put a k on that. Because you could say start at pi over 2 and add another pi over 2, or add a 2 pi over 2, or whatever, to get to a different asymptote. Now, how does this work? Because this is the same thing. This simplifies to pi over 2 times 1 plus k. Does that matter at all? No, because k is an integer. So 1 plus k versus k, same thing. I would accept either one, but just know on the AP test, they might not have this version. They would have just this version. All right. What about the range? Range is just getting this from my graph. The bottom branch goes from -infinity to -2. And the top branch starts at 0 and goes to infinity. All right, last example, might as well do a secant graph. So for this example, let's work on it a bit. Think of it as a negative cosine graph and factor out a 1/2. So if you divide each of these by 1/2, pi over 2 divided by 1/2 is the same as times 2. So that's a shift of plus pi. And if that's confusing to you, once you get your answer, just think about distributing the 1/2 back through to see that you would get this. A negative cosine curve starts below the midline, like this. So that's my reminder there. Amplitude on this is 1, even though there's a negative out in front. Remember, amplitude is the absolute value of A. It's just telling you the distance between the midline and a max or a min. The period is 2 pi divided by 1/2. So that's going to be 4 pi. All right, so let's mark that all the way out here. 4 pi, 2 pi, cut that in half, pi, cut that in half, 3 pi. So we're putting tick marks every pi units. That's how far apart the points are. We have a shift to the left, pi units, and no vertical shift. So left pi units, let's mark off where negative pi would be, and let's move our new starting point that way. All right, so the negative cosine graph starts below at its amplitude. So it starts at -1. And then the next point, remember, these are all pi units apart. So there's like a tick mark here at 0. So the next point is on the midline. At pi, you're above the midline. 2 pi is on the midline. And 3 pi is 1 unit below the midline. Draw in the asymptotes. Now, here's the thing where it can get confusing. So maybe once you get your midline started, maybe you erase that. Or if you do that in pencil and you do your asymptotes in a different color, that might be helpful, because here, I'm going to do this. So this was my starting point, but I'm going to do the vertical asymptotes in blue. So the vertical asymptotes are just where the graph is hitting the midline. And you want to be careful that you don't treat this as an asymptote. So if you need to erase that after the fact, or if you want to just not draw it, that's kind of up to you. And then the branches on the secant curve just open away from the midline. So it would be like this. Here's the one period that I have, because here's my cosine curve, right? Cosine curve is like this. On our homework, we would be extending this all the way across. So you would finish off these little half curves. What about the domain? So it's always all real numbers. What is x not equal to? Looks like we're at 0, 2 pi. The next one would be at 4 pi, 6 pi. So these are all multiples of 2 pi. Or if you're not sure on that, you can say start at 0, add the distance to the next one, which is 2 pi, and put a k on that. Same thing. Simplifies to the same thing. The range is -infinity up to -1 and +1 to infinity. All right, so the phase shift is not too bad. I highly suggest drawing in, just like we do for midline, drawing in what I'm just going to call a starting line. There's no real official term for that. And come into office hours if you need any help with this.